Good morning to all. A warm welcome to the last day of the workshop. Sir, shall we start?
Good morning to all of you. And as promised yesterday, we are going to see some basics in the plotting package in LaTeX, which is known as TIX. So we have already seen, we already had an extensive discussion on the plotting software, the plotting package PSTrix. And PSTrix is actually one of the most oldest and one of the most successful packages in LaTeX for drawing. And that's evident from the number of tutorials available in the internet about PSTrix. There is actually a dedicated page for PSTrix in the uh, text users group, I think TUG. But Tix is relatively new. Being relatively new, it has certain advantages as well as disadvantages. The advantages is that it has been designed keeping in mind certain shortcomings of PSTrix. For example, when PXTeX was defined, when it was designed, the PostScript, DVI, all these six were the usual output format in taking in preparing documents. But after some time, what happened is that PDF became the standard output format for any of these files, and therefore PSTrix is. We have already seen that we need to process it through several steps. Like we need to prepare the DBA file first, then we need to convert it to PS, then to PDF. Even though automatically these things are being taken care of by the software itself, LaTeX editor itself these days, there are several steps involved in that. But Tix is not like that. Tix is actually built over PDF itself. So directly you can use the PDF LaTeX command. That is helpful in certain situations. For example, yesterday itself I told that we need to use ZLaTeX if we are not using that sequence, that DVA to PS to PDF. We need to use ZLaTeX. So not most of the people may prefer ZLaTeX. When we are sending the file to someone else, they will be simply using PDF LaTeX. In such a case, PSTrix is not going to be helpful for us. It can create some problems. The disadvantage is that TIX being relatively new, the documentation available, though there is a very good documentation available, the official documentation is available there. So the help tutorial, etc., are much less compared to PSTrix, it seems. But being something what you call designed after PSTrix, after seeing the shortcomings of that, the commands in TIX seems to be somewhat more sensible and more user friendly compared to. Commands in TIX is comparatively more user friendly compared to that of PSTrix. So we will be seeing only a very short version of this TIX. Since you have already seen what PSTrix can actually do, what are the types of commands, since PSTrix is also a predecessor of TIX, and TIX is evolved on the foundations of PSTrix, on the logical foundations of PSTrix at least. So many of the commands you will be able to quickly guess in TIX comparing to PSTrix. Therefore, even if you are getting a short version of this TIX, I think that's more than enough for starting working in TIX. You can later pick up using the manuals. You can find your own commands, whatever you need, and you can proceed like that. So let us start doing something in TIX straight away. We will be seeing only the basic commands, and I will try to give you a few examples in which TIX is actually very useful. Let me start sharing my screen in Overleaf. So we are going to create a new file here in Overleaf with the name 01 March 01 ticks. Okay. So as in the case, we use the document class. To be article. Remember that here we don't require ZLaTeX, so we can, the default thing we can use as PDF LaTeX. So to start using TIX, we need to include a package. As in the case of PSTrix, we need to include a package. As in the case of PSTrix, once again, the package name itself is actually the software name to which we are referring to, which is TIX, TIKZ. So we are going to use that package. Use package TIX, begin document, end document. That's a default thing. Now, as in the case of begin PS picture, end PS picture, here also we need to, in the case of PS6, it is not that necessary, it's not compulsory. But here we need to enclose. Here we need to enclose this TIX commands in a TIX picture environment. Just like a PS picture environment, we need to enclose everything inside a TIX picture environment. That's necessary here. So let us start TIX picture environment. You can draw some parallels with basics. There we start begin PS picture. Here it is text picture. That's the difference, and that's the only difference. Now let us start drawing a straight line. To draw a straight line from one coordinate to the other coordinator, the other one coordinate to the other coordinate, the command is very straight. Just draw. You need to specify from where to where. So 0, 0, then put two hyphens, 2 corresponding to 2, 1, 1. Let us see if it's working as expected. And one more thing is that after every text command, you need to put a semicolon to end the command. Compiling. Sorry, the spelling is wrong. So a very narrow straight line is drawn from 0, 0 to 1. Now let me update. Okay, I need to share the link of Google Documents. I will do that. Just 1 second. So this is the link. The code is now updated. This is a very simple command. Now either you can continue with this 1, 1 to 2, 3, or you can even continue from here onwards. So consecutive lines also can be created using this. So 1, 1 to 2, 3 to say coming down 5, 1, say 5, 1. So in such a case, you can even create a full rectangle if you want. So you need to just go from, suppose that we start from, maybe we'll create a new text picture environment. So even for creating a full rectangle, you need to just keep on giving the coordinates 1, 1 to say 2, sorry, 2, 0, 2, 0, 2, 2, 2, 2, 2, 2, 0, 2, and finally to 0, 0. So the last semicolon is probably missing. Okay, last bracket is missing. You can see that a full rectangle is here. Okay, so this is a straight, this is a simple draw command. So you need to just draw. Now, just as in the case of PS tricks, we can turn on grid. But the surprising thing here is that even though this is formed, the ticks came much later, PS tricks came into existence. The grid command is not very, I found at least. I found the grid command to be not that interesting in the sense that it is not showing the coordinates. It is not actually showing the coordinates. So, in case we want a grid, we can turn on the grid by drawing the lines grid. So we are going to draw a grid. From where to where we have to specify once again. Draw from suppose 0, 0 to where we have to 2, 2. Therefore, let us take it to be 3, 3. since we are drawing it from 2 to, we will otherwise we'll take it from -1 -1. Let me plot a grid, declare it to be a grid. So because see, this defines if it's an arc, if this defines if it's a straight line. Here instead of that, we are giving it to be a grid. 2 2 0, say for example. So uh, let us keep the height to be -1, or okay, grid is at the top, bottom left corner to top right. So let us keep it to be 3 3. Okay. But now only the grid is shown. What happened to the other things? Oh, because the grid is completely shown, so that the entire triangle is over these lines. That's right. Okay, instead of the triangle, then probably we should, maybe we can make it, okay, because triangle is sorry, rectangle is completely over the grids, so we cannot see that. So instead of that, let me make a different figure, 0 0 to 2 0. Let us see how does this look. Even now, the problem is that the grid lines are very are having exactly the same thickness as that of this the main drawing. Therefore, we will declare this to be help lines. So this is actually kind of suppressing that thickness of the grid lines. Grid is just drawn as a help line. Help line simply reduces the thickness. Okay, now we can see that the grid is completely entirely there, but now the only problem is that the coordinates are not visible. Okay, so we will see how to solve that. We can see later. So this is how we draw some simple pictures. Now, see, there is an option to scale the picture up or down. That's also quite possible. Scaling the picture inside this begin text picture environment, scaling can be done by just using the scale argument inside the scale picture, inside the text picture. Scale equal to 2 times. So it will be, this is equivalent to just drawing a larger line, of course. But the thing is that if you want to immediately scale without worrying about changing each and every command, if you want to just see the effect of that by scaling it up, you can use the scale argument, optional parameter with that. And just as in the case of scaling in the x direction, y direction, here also you can do that. Here x scale is also there, x scale, y scale is also there. So it will be enlarged only in the x direction, and therefore you cannot expect a uniform picture because only horizontal scaling will happen. So similarly, y scale is also there. Now, if you want to put an arrow mark, suppose that we want to put an arrow mark, which we usually require while we draw diagrams. So if you want to put an arrow mark, then we should use an extra parameter, like this is just a line. Just keep it as just a line, removing the help line also. So in square bracket, we can give the arrow mark pointing where 0 0 to. So let us take 5 0. 0 0 to 0 5. Oh, but still the column is missing. The scaling is not necessary here. Now the axis is created here with arrow marks. Now if you put an arrow mark in the reverse direction, that arrow mark also will be, the arrow also will be reversed. For example, if you use from suppose that you are drawing from this to 2 2, suppose you reverse the arrow mark direction. Now the arrow mark is not clearly visible. Okay, maybe we can take it to be 1 1 instead. And we can even make from 2 2 to 3 3, or 2 1 to 3 3. We can even have the vertical line here to get a vertical line as the starting thing, a small vertical bar. Now, if you are drawing continuous lines, and if you want the arrows to be placed at the beginning and end, then you can do something similar. So, for example, suppose that you have from uh, 0 1 to 1 3 to 3 4. Suppose that you have arrow marks. Suppose that you want to put arrow marks. Then if you put like this, only the first and last are arrowed. Only the first and last. If you simply remove this, then only the last one will be arrowed. So Tix understands that what exactly you want. Now, if you want to change the thickness, just as in the case of LaTeX commands, just like in the case of LaTeX, we usually use for enlarging fonts, we use large, large, huge, huge, etc. Just like that, here also we are not specifying the thickness directly, but instead of that, we are using the words thick, very thick, ultra thick, like that. This line has become thick. Now here, thin is also there, and ultra thin, of course, and very thin, semi thick, thick. These all commands are there. I think semi thick. Okay, let us try to see that. No, I think semi needs to be used together with this, but ultra is fine. Ultra thin, all such possibilities are there. And of course helplines are also there, but helplines will reduce the not actually the thickness, it will make the lines a little bit gray. Lines will be made gray, And of course, we can use the width if we like. Then the width line width parameter is also there. Go to 1 centimeter. That'll be too much. Uh, you can specify in point. And can be even dashed or dotted. Because of this, the width parameter, they look more or less the same. So let us change it. Let us make them standard to see the correct effect of that. The color codes can be straight away given. We can check the documentation for all the possible colors like black, gray, dark gray, purple. All these things are there. Teal. Let me update the Google document. Done. Updated the Google document for with the code. Now, instead of specifying the all the four parameters, we can directly use the rectangle instead of see that between bottom left corner and left bottom corner and right top corner, if you specify the argument to be rectangle, the rectangle will be drawn. If you just put some double dashes, two hyphens, then a straight line will be drawn. Okay, the draw command is that much flexible. Only the draw command we need to use for all these things. The extra parameters we need to specify. That's why I told that it is much more user friendly compared to Pastrix because the commands have been designed after seeing the complexity of certain commands in Pastrix. So let us try to draw. Begin, end. Remember to give the semicolon at the end. That's very important. Just remove this. So 002 32, not line, but instead rectangle. So we are defining the corner. And just as in the previous case, we can have several other options like so 1 1 2 3 1. No, sorry, that's not 3 2. So all these commands can be even given here. Drawing the circle is also similar. As we can expect that for drawing the circle, we need to specify the center, and after that, instead of the next coordinate, we need to give the radius parameter. Specifying the center, say 5 5. What do you want? Just explain and give the radius in square brackets, because draw actually expects the two coordinates as the compulsory parameters. So here we need to specify the radius instead. 0.1 centimeter, I don't. Okay, let us try that. Should work. So the starting point is supposed to be 0 0, and 5 5 6 6 etc. is everything going upward. Now arc also can be prepared like that, but for the arc, what we need to specify is we need to specify the starting point, and then we are going to give an angle. So we actually specify two angles. One is starting angle and other is end angle. Let us see that how is this going to work. Maybe draw from where. Always we have to specify that from where, center, all these things we are specifying. Suppose 4 4, which we have not used so far. Arc. This is what we are going to draw. But what is the radius? Radius. Okay, let us see the radius itself, and let us see that how is going to work. Radius 1. Is this enough? No, we have to specify this start angle, and okay, 4 4 arc. Radius is 1 centimeter. Even that's not enough. 45. Let us see the effect of this. Arc radius. Let me just copy this to a new environment to see it clearly, so that we can identify some mistakes are being made. After that, we will club it with a circle. Even 4 4, I think this is too large. Let us keep it to be 0 0 itself. And let us put some text also to identify if something is. actually happening. Drawing an arc. What is that arc appearing somewhere? That's surprising. Because probably, okay, let us change this. This is because of this one. This has come now. So 45, what's happening? Probably it's coming back to the same angle. So if we change it to 90, what will happen? I think the starting point is here. We are beginning at an angle of 45. We are beginning at an angle of 45 here. After that, we are ending at an angle of 90. This is how it's working. So if we take it to be 270 then, and with a radius of 1 centimeter. Okay, let us try to club these two with a circle. Radius 1 centimeter. At the center, this is this is starting point, not. So if you have four four as the center, then radius is, so we can start at 0. Okay, 4 4. It is not going to cross. Okay, let us keep this as 0 0. Radius 1 centimeter. How to place this arc over this circle? Let us just try to see that. 0 0. This is 1. Let us start. Therefore, it's going up to 1. So let us take it to be uh, 0 1. Radius is 1 centimeter. Okay, let us see how is this appearing. Maybe we can change the color also to see this. Blue, thick. Skip the options. It is starting at 0 1. That's fine. Then it is going at an angle of 45 degree from there. To which direction? Zero 1. Let us just try once again. So suppose that instead of, let us start at 1 0. So 45, 90, radius is 1 centimeter. Starting angle is 0. Tracing 180. Line width say 0 point or 5 pt. Okay, seems to be fine. So we can create an arc like this, drawing an arc above. So we have to start with 0. And if we start, okay, if we are starting with zero angle, it will be making initially zero angle with the x-axis. Then we are proceeding to, we are actually, okay, zero angle. After that, we are making an angle of 118 total with 118 total with a radius of, so what is this? Okay, arc with an angle of 180-degree angle, it's covering radius 1 centimeter. Starting angle is zero. If you keep the starting angle to be zero, it will be tracing this complete circle. That's the easiest way to understand probably. Now, just as in the case of arc, we can actually plot curves also. So this is an arc. So arc and curve, that doesn't make much. So if you want to draw a path from one particular point to another particular point, suppose that we want to draw a path which is a kind of a curve from one point to another point, which is very useful if we are trying to construct some graphs in graph theory. So this is going to be useful. Draw from 0 0 to 2 2. Okay, let us see the effect of that. This is just a line 0 0 to 2 2, but we will specify some degrees that we are starting with 90-degree and ending with some higher degrees. So in degree and out degree will specify. Out degree, going out is from the 0 0 with 90 degrees. So we are starting vertically upwards. Out is 9, and in degree, that means we are coming in towards the end point. Let's say 180. So how does this look if we specify the angles like this? But we need to give it here instead. So you can see that the starting angle is 90-degree and the end angle is 180-degree. Starting angle here, this is 90-degree and we are ending here at 180 degree. So where did we stop? At 2 2. Oh, finally we require in degree to be 90. Zero 0 to 2 2. In degree is 90. That's too sharp. It's better. Or if we give 270, so you have clubbed two curves. And instead of these things, you can actually make consecutive curves by placing consecutive twos like this. So 0, 0 to 2, 2 with this angle, and 2, 2 to 270 in this, 2, 2 to 5, 5 with this angle. 90, 180 angle in the first one, and 180, 270 in the second one. So this is also possible. Now plotting functions is also very similar. We have to use the draw command along with, see, every drawing is actually accomplished by the draw command, but in addition, to draw what we need to specify. If we are specifying or if we are giving it two coordinates, so whatever is following after draw command will be drawn. Okay, but there we need to give extra parameters. Okay, let us try to note the graph of x square. Let us draw the axis first. -1, -1, 2, or otherwise let us take it symmetric, -3, -3 to 3, 3 with the arrow mark. Oh, this is not axis, sorry. -3, 3. I should take -3, 0 instead, sorry. X 0, what I exactly want? I want x axis to be from -3 to +3. Therefore, x axis -3 is -3, 0 to 3, 0. So, on the other hand, 0, -3 to 0. This should create the axis. So the axis is now plotted. Next is plotting the function. For plotting the function, we need to specify the range by giving the parameter domain. So let me plot domain from -2 to 2. I'm going to plot x square in this domain. The command is to plot what? So x is the varying thing. So x, we have to plot the points x and f of x. So f of x needs to be specified inside this. I think x square. I don't know whether squaring is possible directly. Is there a power function? That's what I'm wondering. Okay, instead of that, anyway, some multiplication is definitely possible. X star x. Okay, let me just see if it's having the same. Basically, xy points are plotted here. So here requires -3, 0. These points are plotted as y is equal to x square. It's a graph of y is equal to x square. That's plot. So the function we need to enclose here. Okay, power also can be used. This is also possible. Power. So this is the graph of x cube. This is x, and you need to specify the function inside this curly braces. X and x to the power 3. This is x and x to the power 3. And of course, standard mathematics functions like log, exponential, all these things are available. Sine, of course. Sine is here assumed to be in we need to specify that it's expressed in radians. Therefore, we need to give the extra parameter x. Sorry, r. So we need to specifically say that this is in radians. Now the other functions are log function is available by default, log 10 absolute value function, square root function, factorial, exponential, modulus, mod, absolute value, mod. They are sorry, mod is not modulus. Mod is actually mod, that modulo function. A tan function, minimum function, math functions. There are a few functions available. You may please check the documentation for getting more information on that. So combining functions is also possible. Like suppose that you want to combine sin x uh, plus x square. So either you can give x star x plus this, sin x plus x square, or even x sine. Maybe I should not take the domain to be this much, 0.01. Suppose I take x sine to 3.14 instead of that. I can take it to be in degree. So let us take degree 1. No, I wanted the x sign 1 by x function. So where should I be careful? Uh, so when it becomes pi, there is a problem. So 0 pi by 2. Maybe I can take only up to here, so that x sine 1 by x can be plotted. Oh, sorry, I wanted x sine star. You can say that this is not actually a very beautifully plotted, because number of points used is very less here. Number of points used for plotting is very less. That's why the graph is appearing like this here. Because otherwise, what happens is that when we are moving towards 0, okay, of course, you have not taken that much the domain to be that close. Maybe we can take it to be that close here. He's not willing to work on that. Because 1 by x is becoming too large. That's the problem. When we have become closer and closer to, when we become very close to this, what do you call it? 0, 1 by x becomes very large, and tech is unable to compute that. So in such situations, remember that tech is not actually LaTeX or TIX or PSTix is not actually the best way to plot when there are complicated examples. So in such a case, you need to make use of some mathematics software like Sage Math, Mathematica, MATLAB for plotting, and then you should import those plots. You may include those plots, and maybe you will be able to mark the labels. You should be able to put some marks here and there. That's quite possible, most probably. So don't try to draw complex things, too complex things in ticks or even PS tricks. They are not actually meant for that. They are not meant for mathematics drawing as such. So they are these graphical capabilities are for placing arbitrary content with some kind of decorations here and there. Don't expect them to be a brilliant mathematics plotting software library. Now, as we have seen, we can fill the space. Remember that when we specify the color, it is assumed to be the color of the boundary line. If we use fill and then say red, it will be filled with red. But if you only want the path to be used, if you do not like that outline to be there, suppose that the outline you are not interested in, because here the outline we can see. If you are not interested in the outline, what you can try is, in the case of circle, you can say that the outline is still there. So if you do not want the outline to be there, see, in the case of this circle, we can see dashed, black, The outline is there. Now, if you fill teal light color, the fill is with this boundary. But if you do not want the boundary to appear, instead of this, you can use. You cannot suppress that boundary in row. You can simply say that you are drawing a path, and with fill, not at 2 2, say at 4 4. Okay, let me update the Google document. With all this, I'm updating the entire document. Update. But at the same time, remember that if you want to suppress this outline instead of path, what you can do is that you can define the line color also to be exactly the same as that of the fill color. If you define line color and fill color to be exactly the same, that has the same effect as that of filling it with as that of hiding that line. Okay, that is also quite possible. So both these techniques will work. Same way you can fill using the arcs also you can fill. Okay. And suppose that you want to fill an arc area, you can define what you call an arc with in degree, out degree, and you can fill. Just like this is equivalent to, if you are filling an arc, that is most probably equivalent to filling what you call a wedge. So let us try to say that we have prepared an arc somewhere here. Here is this arc. So you can fill this arc. The arc is given here. Suppose that you want up to 30 degree to be filled. No, this is not actually the way to fill. The arc is not getting filled as I expected. Maybe I should use the path for filling. So let me take a path. Let me define a path first of all. Define two paths. How do I do that? Maybe I can define a path. So this is 0 to 30 degree. Okay, that's fine. This is defined. Now, where would I have reached? So this is circle with center 0 0 and radius 1. So I need to start at this. Okay, maybe instead of this, I will start drawing a path using. I need to fill a path. So how do I define this path? So I wanted the path from. So which point to which point exactly? So if I use Okay, let me just try to do that. I'm not very sure about how to do that, but still let me do that. So 20, I definitely need from, this is from 00. Okay, let us try that. So path, let me try to do that. Let me try to give a path from 10 to, without degree equal to, outgoing degree equal to 0, in degree equal to how much it is, 30. We try, and then going up to which point. Okay, let me try with the easiest thing, up to say 101. Let me see first if it's working fine. I'll proceed with that. But in degree in that case should be 90 degree, right? So let us draw instead of, so to see it completely. Oh, what is this? Okay, the circle is anyway there. Should be 180. Perfect. 90 to 0. That's a path. Okay, from here, I should draw another path. To where? To the center I want to draw. The center is 00. But now, out degree should be how much? Out degree should be, I need to come down. So from here, the out degree is going to be, is it going to be 90? I don't know, I will try. Out is 90. And when it is coming in also should be, is it 90 or 270? Okay, let me see that. To 00. But wait, this was not actually necessary because we are, this is not necessary because we need only a straight line here in this case, right? Arc is not necessary. So 01, 2, this is more than enough. 01 to 00. Perfect. Now 002, where do we want? 10. Okay. Now let us fill. Let us make this as a path, and we can even fill this directly. Fill. Done. Now reduce the line width. Let us keep it the default. Now the question is, can we specify some other point? Suppose that by the degree can be specified up to sine 30 or something like that. That's what I'm wondering. Can we specify instead of 10? Maybe that should be possible. Okay, let us see that later. I don't exactly know whether it's possible. So this is how we can fill some arbitrary space by Drawing, it is if you do not want the outline to be drawn. Suppose now we completely remove this. Suppose now that we completely remove this and even keep only this, only the arc will be there. Okay, only the arc, only that circular wedge, not arc exactly. Only that circular wedge portion will be visible here. So this path can be, after drawing a path, you can fill any area that you prefer. That's the most important thing. So if you draw a path from anywhere to anywhere, you can get an area, a colored area of your choice. That too, depending on the way in which you want, you can connect any polygon, and you can fill that in this way, but without having the polygon boundary. Without the polygonal boundary, that's the most important thing. Now we may want text also to be written on this. So for that, we need to create something called node. Node. So let's draw this circle. Text at coordinates. So if you okay, if you want to place something at somewhere, so we need to create a node. Node at which point? You need to say at which point you want to create the node. So at the center, 0, 0. So at nodes we can keep text. It's too large. Let us make it slightly, or just even O itself is more than enough. Capital O, but not at the center, slightly below that. So radius is 1. So let us make it 0.2 somewhere here. So you can place text anywhere. And instead of doing all these things, there is an easier way to do, because we had to adjust where exactly we wanted that text. So even instead of that, we can simply say that below option we can specify. Below 0.0. Serious. Below 0.00, below point 0, which one is this? Below this is a relative position. This is an approximate position, of course. If you want a full control, like where exactly you want the text to be placed, you need to then uh, determine the position in your own. If you do not want to, if you do not want text to take care of that, you do it yourself. So below you can do, right you can do, left you can do, up you can, up you can. Sorry. Can you mix above and right? I don't know. I'll try that. Which is getting affected? Only right is getting affected. So above right is not going to work. Above right is working if you give it like this. So this is much more useful. This is much more friendlier in the sense that whatever we usually expect can be straight away typed in certain situations. So this is actually the text color above left purple. So you can give the color also, and of course you can scale. So x-axis, y-axis also can be using this above, below, all these things. You can use x-axis, y-axis kind of marking also you can make. And in fact, you can mix up also, the sense that suppose that you want to write in between instead of waiting for the drawing to complete and issue a separate note command. You can keep on drawing and keep on writing. Suppose that you are drawing a rectangle or a path, not rectangle, a path. Of course, the path with lines shown from 00 to, okay, we are starting with 00. So below 00, we will probably mark not. This is a not. Okay, declare it to be not. 00 is a not. So below that, let us write origin. Now continue to 1 2, make it as a not, And above, let us write the point itself, maybe in math mode. Continue. To 4 4. Note, maybe to the right of that. Text we will write as 4 4. Done. There is actually a very good command using which you can draw multiple lines in a loop. That's known as for each. So, if some of you are familiar with programming, it is very easy to understand. Otherwise, also it is not very difficult. So, suppose that let us draw concentric graphs, concentric circles. So, for each concentric circle means radius we are going to vary. In radii, we are going to take it to be, I don't know whether I should 0, 0.1, say 1, draw center at 0 0, circled with radius equal to, I think this is the way to draw. Let me try. Great, it's coming anyway. Radius equal to 0, radius equal to 1 is anyway coming, but row 0 0, that's a problem. Okay, let us, what was the format, what was the syntax to circle here? Radius equal to 1 centimeter. Maybe I should specify this as centimeter. Why is it not working? Circuit. Draw. Oh, text picture. That's missing. Is it because of that? Let's see once again. Great. So here what I have done is that I have created a loop kind of. So for each R in, this means that I take R to be 0 first, which is a point, of course. Or maybe I can take it to be 0.1. Then 0.1, after that difference will be 0.2, 0.3, etc. to 1. Draw radius, draw circles with this radius with center at this. Okay. This is how we can repeatedly create, if you want to repeatedly draw something, repeatedly draw some lines, we can make use of this for each command. Okay, such commands are available in PSTrix also, even though we haven't discussed that. I think the command name is multi-do. So do something multiple times. That's multi-do. So for each is also something similar to that. Maybe if you change this, suppose that you are changing this from R, so the X we are changing it, suppose, then we are slightly changing the center and radius we are increasing. Okay, we have update the Google document with this. See, this technique actually can be used for what you call marking the points in the grid. So we have seen that even though we have grid, that the grid points are the coordinates are not marked. So if you want to get an effect like this, you can actually make use of this four each. Let us try to see how to do that. So we are going to see the coordinate marking on grid. So grid is here. Let's copy this example. So we can make use of the same this. a node command we can actually make use of. So in a loop, we will try to put at each and every. For example, here we are inside from -1 to 3 3. So we are plotting a grid. We are plotting a helpline. Okay, instead of -1 Okay, let us keep it to be like that. -1 to 3 3. That's fine. So otherwise, maybe even 5 5 to make it a little bit large. So we are going to make use of this for each. So this is how we have done. Now let us mark on the x and y axis. If we want to put the x and y axis also, we can even do that. So x axis is done. How? X axis. So how do you do that? Uh, -1 -1 to 0 0. Here we will mark a node also. Below that, we will type. Okay, this is not necessary. We are going to anyway type it separately. So -1 to till where we want 5 5. We have grid lines from 5 up to 5 5. So 5 5. Node is not necessary here. Node we will mark simultaneously, and we will put an arrow mark also. -1 to, sorry, not -1 to -1 0. So sorry, 0 -1. We want the x to be from -1. So -1 0 to 5. So this is so, so the axis is marked here. Now the y axis also we will draw. Maybe below that, below we can write in node below that this is y, and the x y axis we are going to mark as uh, y axis. X is 0 -1 to 0 5. We will mark it as left. This is x. This is y. X is marked. Y is also marked. Now we will mark the coordinates. So what are the coordinates that we should mark? We need to mark the coordinates 0 1, sorry, 0 1 2 3 4 5 along the x-axis at these nodes. So we are going to make use of a for loop for each. Zero also we will mark. Maybe zero we can treat separately. Otherwise, it will be 0, 1, 2, etc. 2, 5. So what do you want? You want to write the node at. So how do you write that? Node at node. Okay, writing is to be node at what point we want. The point we need to specify the xy coordinates. So the x coordinate is here. The y coordinate is 0 because this is on the x-axis. So node at that's wrong. Node at that's wrong. Sorry, this we need to specify in the beginning itself. This is an ordinary bracket. The text we have to write is in the other packet. Is it correct? Let's see. But we don't want the y coordinate there. So also let us keep it to be tiny, slightly left. Fine. In the same way, you can actually mark. If you are going to mark in the same way, then instead of x0, you can put 0x. Remember that this x is just a variable name here. Doesn't mean that we are going to put it on the x-axis. So instead of below left, we should put probably above left. So we have marked a coordinate system using for. But remember that compared to PS tricks, here we are able to do things in the way in which we actually want. It's much more that the friendliness of the commands is what I feel in my personal opinion is that the friendliness of the command is much more comparatively other than compared to PS tricks. Let me update this once again. This coordinate system is going to be very useful, especially when we are trying to do something, when we are trying to place some text somewhere. Suppose that once you write this coordinate system, you will be able to write wherever you want. By looking at this coordinate system itself, you can do whatever you like. So I think some of the basic commands that we will be using has been almost covered. Now let us see some more examples. So we have seen how to draw lines, how to draw diagrams, how to write inside text, how to write inside specific notes. Now, if you want to add some text inside some box, so instead of placing the text arbitrarily using the not command, there is some extra way so that you can keep the text inside some particular box or circle, all these things. Okay, we will see that. So text inside frames. So for that, the main focus is on node, not on drawing. Main focus is on node. Just 1 second. So if you draw, if you simply place some a draw parameter along with draw option along with node, what will happen is that a box will be drawn around the text which you are using. Node draw at 0 0 text in a box. And if we change this to, okay, here it's automatically a box. Let us try to change it to circle. I don't know whether it will work. Let's try. Okay, that is not appearing. Node. So how to achieve that? See. Okay, probably that the size, all these things we need to specify. And okay, we just try. We are going to draw a circle. Draw is not happening. Draw the circle. Together with that, let us add some options. The radius we need to probably specify, not the radius here, the size of the circle. Size once enabled. Let me just try. I think it is because we are drawing at the same place. So instead of 1 1, let us keep it at 2 2. So that's why the box is also coming. Sorry, that's not. So what we have done previously is correct. So this is not, see, minimum size is actually, it simply means that we are keeping the minimum size to be something like this. This is not necessary. So if we keep the minimum size also, what will happen is minimum size equal to 3 centimeter. I think that the size of the circle should increase, not up to 2, 5, 5. I think it's already minimum size is 3 centimeters given. Therefore, the size has gone up. Okay, we just try to see. Yeah, so you can increase the size of that. Now, if you want to plot a graph, so what you need to essentially do is you need to just 1 second. I think the command text I need to plot. Okay, just 1 second. I will try to plot a graph also before coming to an end. Begin. So let me draw. Draw is not necessary. Node at some specific positions. Let us keep it to be 0, 0. So this is an attempt to draw a graph theoretical graph. We have a dot here, but you need to probably write above. Something like U1. I don't know whether there is any other way to do that. Maybe we can have some extra better options are probably there. Try this as U1. Now you can draw in the similar way. You see, you can actually keep on. I don't know, in a loop. Can you do that? Maybe should be able to. 0, 0 at 0, 3, 0, 3, U2. What is happening? Okay, U1 and U2. U2 has gone up. So U1 and U2 you can draw. Okay, 0, 3. I want this to be a 3, 0 instead. Sorry. 3, 0, 3, 0. On the same line I want. Now to connect between these two, in fact, you should have directly used it. Draw just a line. It's not necessary to even specify that. 0, 0, 2, 0, 3, 0. So connected. So in this way, you should be able to. So in fact, instead of doing all these things, but the only thing is that you require a text bullet. So if you definitely want to put a dot there, I don't see any other way to put a dot there, because the end of this is going to be okay. Let me just try to see something. If I can put a dot as the end point, is it possible? I don't exactly know. Maybe I should be able to do that. In that case, I need not do any of these things. 2 2 2 3 3. That dot is not appearing anywhere. Okay, if I change this to a text bullet, can I get a dot? No. You need to probably define your own dot style for that. It seems anyway this is not going to definitely work. So this is one way to draw graphs. If we have understood the way in which we have drawn graphs using PS tricks yesterday, you should be able to complete. So you should be able to complete between nodes. You should be able to. We have already seen that how to create circled text. So using nodes, you can using this node command, you can definitely come down. So these are the things that I wanted to discuss basically about ticks, and the other things we can quickly get from the documentation. There are very good documentations, of course, available, even though it is not as. Sorry, is there any question? Okay, so what I wanted to say is there are good documentations available, and there is actually a very good book like called "Ticks for the Impatient." But unfortunate thing is that that is actually in French language, but the code is of course in English. Code you can actually copy and paste, and you can try what exactly is happening there. And a minimal introduction to ticks. There is another documentation available. Minimal introduction to ticks. That's one. In fact, we require only minimal introduction. After that, we can pick up. And this is another one. This is actually written by Ticks for the Impatient. Is actually written by the creator of Ticks. The creator of Ticks is exactly, I think, the same as the creator of Beamer. So yesterday, I think there was a question whether we can use PS Tricks along with Beamer. Of course, we can use, but the thing is that you need to use a DVA first. Then you should go to what you call PS. In that way, only you should process. Otherwise, it won't work. But here, in the case of Tix, it's not like that. Tix you can straight away use with Beamer because it's already a PDF LaTeX compiling thing. Is this Tix code is compiled using PDF LaTeX, not using DVA or PS. Now, one more thing is that most of the times we want to prepare something like a certificate, something like a poster, and for that, I'm not going to explain how to do that because they are all using ticks. So instead of we trying to design something in our own, there are some excellent packages available. There are some excellent packages available, downloadable files available in the internet which uses ticks, and certain modifications if you make into that, like changing the background, changing the font here and there, changing the text, you will be able to make beautifully prepared documents. You can quickly make. It's very easy. Now I will show that link to that. So certificates. Let me just take to that page. So this is a tech.stack exchange page. So this is actually a page from where you can most probably you will not be able to ask questions. I think you need to create an account, free account, of course. But the thing is that for most of the questions, authentic answers can be actually obtained from this site because many of the times what happens is that the experts in tech usually come here and answer instead of some ordinary users also will be answering here, but experts usually come here and answer. So I'm sharing that link. So this is not exactly a package, but this is actually a set of files prepared by someone and shared for all of us. The only thing is that you can see here, you can see here that someone was asking about uh, certificates like this. So there are some answers here. There is some code also given here. You can just copy and paste the code from here. See, here you can see that certain packages are being used here. Packages like here that Tix package is not being used. I think something below. Yeah, this is a kind of this is the kind of certificate that is being issued by many mathematics people these days by copying this file and modifying it slightly here and there. And one advantage of this certificate, this particular package, is that so this actually makes use of packages like PDF space geometry package, which we have already mentioned. Calligra, that's a font. Fourier Ons, that's an ornamental graphics package, ornamental font package. There is a wallpaper package for placing this background. And after that, there is a data tool package. Using this data tool package, you can see the example and you can easily understand what exactly this is not a very huge code. The code consists of only a few, at most 100 lines or something like that. So what happens here is that the certificate is once you keep the names and institutions of the participants in an Excel file, not exactly an Excel file, that needs to be converted. That Excel file needs to be converted to something called CSV file, CSV, comma separated values. After converting that file, certificates in which names of each and every participant and the organizations of each and every participant will be appearing in different pages. So you need not copy and paste each and every name. Directly, you can import the names and organizations from an Excel kind of file, and you can prepare the certificate. So this is one package that I would like to mention about. So you can see several examples here, and you can see this is also one. And this actually refers to something else, I think, using nice frame and wallpaper package. These are also some packages. The essential thing is that the background you are supposed to get. The background you are supposed to get, you can download the background, and this page actually gives you links to the page from where you can download these things. You can download all these things. From this page, you can find link to that. This very page, you can find links to page from where you can download these backgrounds, and of course you can add your own background. You can get backgrounds more from Google. Everything is possible. And in addition to that, there is actually a package for preparing poster, which is based on Tix, which is that class is known as BA poster for preparing poster. So BA poster template you can uh, get from GIT Hub. From here you can get a GA poster package. You can see you can download that package from here, and examples are also there. So this is the poster package, and this basically depends on text. So if you have understood some text command, you will be able to understand that what exactly is happening, and you will be able to modify the code according to your choice. So I think that's it about everything that we have been discussing so far. Probably we will stop here, and I hope that I have been able to convey certain things which are useful to all of you, at least the basics from where you can pick up. And if there are any questions, clarifications, I can try to answer. Thank you very much for your patient listening for all these 15 days. And I would like to thank the University of Calicut Department of Mathematics also for giving me an opportunity to give a few lectures in this workshop. Thank you very much, and I am probably stopping. And if there is any feedback session or anything like that, I request the coordinator to take charge of that. Thank you once again. I will update the Google document with whatever I have typed so far.
Thank you, sir. Thank you on behalf of the Department of Mathematics and participants. Now, without any hesitation, I can say that we are very fortunate to have such a resource person as you. I'm sure that it was a wonderful experience for the participants. And I think the way of presentation and sharing the source code in Google Docs is very effective, and it would benefit 100% to those who listened and practiced in the class. On behalf of the organizing committee, I also take this opportunity to thank all participants for being a part of this workshop and making it a success. Now, participants can share their feedback, and we are very happy to hear from you. So, participants, please share your feedback.
Good afternoon, sir.
Yes, continue.
I am Kirtana KP from first MSc Mathematics student. Enormous and most sincere thanks for the workshop on 15 days. Thank you so much, Vishnu Nambudiri sir. Really appreciate the wealth of knowledge and insight you have shared on these days. Actually, we are not familiar with LaTeX. Your class is very inspired and motivate us for learning LaTeX. The way of approaching new concepts is more interesting to us. We can easily catch them. We are used this overleaf for the first time. That was not affected to us. Your way of approaching helped to us how to write something by using this, and class is more comfortable to us. The sharing of Google documents that are more comfortable to us learning this. Now we are familiar with the article making, book making, question paper making. We got knowledge about commands and the importance of use packages, how to write theorems, construction of equations, the representation of circle, parabola, ellipses, coordinate representation, matrix representation, bibliography making, etc. are very useful to us. We can easily catch them. We know that in online platform more difficulties are there, connection problems, something like that, but that was not affected to our class. I really appreciated hearing about your creative process. It was extremely useful. Through these days, we have covered lot of parts. It was great to your kids. Thank you so much, sir, for sharing detailed, honest information. And also, our lot of thanks to HOD Anil sir and Sini ma'am and the entire mathematics departments for giving this opportunity to learn LaTeX. Thank you so much, sir.
Thank you, Kirtana.
Good afternoon, all. Without a doubt, I could say that this 15 days workshop was very informative and useful. Thank you, Vishnu sir, for taking your precious time. 3 hours per day is not so simple task, but you handled this session in an organized way and you explained everything well. Uh, Without just sharing information, you also tried for our active participation. You shared codes with Google Documents and recorded class and uploaded in YouTube, so that we can go back to that while we stuck in typing. These were very useful, sir, and you have properly guided us uh, to the path of becoming a good LaTeX typer. Thank you, Vishnu sir, for such an informative workshop. And I also like to thank our HOD Anil sir and Sini Miss for conducting such an informative workshop and also for choosing such an apt resource person. Thank you. Thank you all once again.
Is there any more interested to share their feedback?
Good afternoon, ma'am. Good afternoon, sir.
Good afternoon.
I'm Deepasri S. Kumar from Department of Mathematics, Acharya Institute of Technology. I'm the professor in mathematics. So actually, I have missed one or two classes, but still, I'm very much happy to say you that it was very informative and very detailed session. Actually, I have learned some very basic from YouTube and all this about LaTeX. But this 2 weeks courses, it is very helpful to students as well as the professors and teachers also. So I'm appreciating you people and for this effort, and I have seen the patience of sir, that Vishnu Nambudiri's patience to explain these and all. I'm appreciating very much for this effort, and we are looking forward these kind of workshops again. Please share everything for us also, please, madam. And thank you very much, sir, for your this effort. And we are looking forward for this type of workshop or FTPs. anything. Thank you, ma'am. Thank you, sir. Thank you, everyone.
I think no more to share the feedback. Now I welcome Miss Priya to propose vote of thanks.
Good afternoon, everyone. It really gives me an immense pleasure to deliver the vote of thanks for this event. There is a famous quote stating, "A moment of difference makes a difference in your attitude." Literally speaking, this workshop happened to be such an experience for me. I personally learned a lot of new things from this workshop. It was really a wonderful journey from the basics of LaTeX to the most advanced graphic tools like PS and Tix. In fact, I'm using LaTeX for the past 2 years, but this was the time that made me to realize the meanings of a lot of commands that I was using quite frequently. Otherwise, it might have been something like searching in Google and copy pasting them in our documents. So, thank you, sir. Thank you a lot for providing an insight to LaTeX. Besides the hectic schedule, all the sessions were very much informative, as everyone has conveyed in the feedback. The once again, the Google document method of learning, it was something awesome. It was quite progressive as well as very much interactive. It really made us to actively participate in the workshop. So, on behalf of the Calicut University Mathematics Department, I would like to extend my heartfelt gratitude to our resource person, Dr. Vishnu Nambudiri, for his efforts for the successful completion of this workshop. I also extend my gratitude to all the participants for their active participation. A special thanks to our beloved head of the department, Professor Anil Kumar sir, coordinator Dr. Sini madam, and all other faculty members of the department for organizing such a wonderful workshop. I also extend my thanks to all the research scholars, postgraduate students, as well as the non-teaching staffs of our department for their wholehearted support. I would also like to thank the government of Kerala for sponsoring this event. So thank you all, everyone.
Thank you, Priya. Now, we are very happy to announce that Department of Mathematics also conducting a workshop on Python from 7th March onwards. And Dr. Vishnu sir is the resource person for the same. So, thank you all. Thank you. Thank you, sir.
Thank you.